First of all, I would like to express my honor to be here to speak with you and tell you about our approaches, how we do R&D in NLMK. Let me tell a few words about NLMK. NLMK is an international meteorological company. We have the main manufacturing site location in Lipetsk. There we produce steel as a steel as a slabs. You know, slabs. It's some kind of big ingots. Partially we roll it in Lipetsk, but partially we send it to our another location sites, manufacturing sites, which are located in Europe. We have at least 5 plants in Europe. We have 3 plants in US, and also we have some number plants in Russia. So NLMK is really international company, and not so long ago, maybe about 3 years ago, in NLMK R&D department has been established, and this is the real R&D. We are trying to not to improve our present product, but really invent something new, which is not present in our product portfolio right now for today. And today I'm going to tell you about how we do it in terms of management approach. Frankly speaking, I don't want to tell you about how we do it in a technological way, because it, for me, it's not so not interest, but you know, there are a lot of really other speakers, I guess, from whom you can know something new about some technique approach. And today let's speak about management. Okay, I can share my screen, right? Pum, 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 pum.
You can, yes, of course.
Okay. And let's start with my own story. When I made my master thesis, I made it in Kurchatov Institute here in Moscow. This is a pretty advanced research center, and what I did there, we tried to invent some magnetic ordered nanostructures which should be a really advanced memory cells. But my team leader and I, we were really experienced in a different technical way. We really knew what to do and how to do it. I mean, to research and develop this this product. But we really didn't know what we have to do next. Okay, we tried to investigate the memory cells, yes, but we didn't know who would be who would be the customer for this technology. So we didn't know who would be the customer. We didn't know who would be the manufacture and how we could manufacture it. We knew how to produce these memory cells in the laboratory scale, but we didn't know completely how to produce it in industrial way. And of course, we completely didn't think about some business approach, how we could promote it as a business. And that would be a problem, and that would be a reason why this technology didn't come to the market as a full product, I would say. So, and today, as I told you, I'm going to speak with you about how to manage and the projects of innovative products, and how to manage with portfolio of such products. So and there is some difference, and I guess in the end of the lecture you will know what different it is. Okay, let's start with a very common, and I don't know if you are familiar with this approach. This is the classical approach how to manage with projects. This is Gantt chart, and I don't know if you're familiar with that. Have you ever heard about this approach?
Yes, we hear about.
Okay, and so just a few words about this. We split all projects with some tasks. Maybe some tasks could be split and with subtasks. And here I wrote it. So let's imagine we have 5 tasks, and task number 4 and task number 5 have subtasks 2 and 3 and respectively. And let's imagine we did this project many times before. For instance, we build the houses, and we build the same houses. We have the same project. I mean the same drawings, and we know that we have to build the walls. We have to build the some communications. We have to I don't know, just input the windows and so on. And we did it many times before, and we know how long it takes each tasks. And we know we so and in horizontal axis you can see the months. Yes, and here we have tasks which go one after another one. So we couldn't start the task number 2 before we finished task number 1, and then we go to the task number 2, and after task number 2 we go to task number 3, and simultaneously go to the task number 4. It could be start, as I told you before, simultaneously, for instance, and then we do 2 subtasks of task number 4 subsequently. And then, for example, to start task number 5, we need to have some period of to stop our work for 1 month. And then we did and then we do task number 5. That's pretty clear. But what if we don't know what tasks or subtasks we need to do for our project, for development our new product? And this is very common for some invention products. So and here we have only some technological part, and but what if we don't know what to do? We don't know how to do, and I mean to manufacture it, and we don't know for whom we are going to do this. I mean, what about the customers? And let's talk about readiness levels, and then we will come back to how to work with such kind of products in agile way, in agile approach. So initially, I would like to tell you about TRL. TRL means technology readiness level. And usually we have, this is a very, this approach came from military military service from US, and NASA approach also from US. And here we have 9 stages. The first TRL number 1 means that we have only basic principle approach or basis, I would say, how to work with new technology. And finally, TRL number 9, we have actual and approved systems which could operate in environments of operation. And this product fully commercial demanded, I would say. Just for in the middle we have different stages of this. We have, for example, TRL number 4. We have technology that it means that technology is validated in laboratory, and we have some small scale prototype. TRL number 5 means we have large scale prototype, but we didn't try it in environment which we are going to apply it. Next TRL we apply in the prototype in environment, in a relevant environment, and so on. Actually, these TRL definitions you can find in Wikipedia, at least in English Wikipedia. This is common open information. But for different industries, we need to modify this TRL definition for our own. For example, in metallurgy, we really have, for example, laboratory prototype. What does it mean? It means that we take some small furnace and melt ingots, for example, 10 kilos, and then we roll it, and then we heat it. We make some heat treatment, and and then we can measure. We have very small piece of metal, of alloy, and then we can measure the properties of the material, of new material, and we can try it. This might be the small scale, laboratory scale, but we completely don't have some large scale prototype. This is nonsense for us. Then after we do something appropriate in laboratory, and the next step is we go to the industrial line, and one heat, one ladle, I mean, what we the material amount, the steel amount which we can melt for one quant, I would say, is 160 tons of metal. This is not completely, it's not a prototype. Please use it, but please also remember that you have to modify the definitions of TRL for industry which you are going to run for. Next manufacturing readiness level is MRL, manufacturing readiness level. The same story. We have 9 points. MRL number 1 means we don't know how to produce a new product in industrial way. We don't know what is the requirements of for this kind of equipment. And MRL number 9, we completely know the equipment, what we need for producing our product for industrial way, and we know the parameters of manufacturing. And the third readiness level is the customer readiness level. Here you can see the definitions of different points for CRL from Rosatom. And from my point of view, I disagree with this scale. Why? Because based on this scale, the contact between R&D department or from our company with the customer contact occurs only for serial level number 8. This is too late for my point of view. I would say that this is very important, that we need to contact with the customer as soon as possible. We need to contact with a potential customer even when we have technology in our laboratory. At least when we have laboratory small scale prototype, that's a time point. That's time to contact with a customer and show him what is our product, what we are going to develop for, who we are going to develop for, and the customer feedback of the customer helps us to specify the requirements for our further product. These contact support us to develop to define the properties of our product. I mean, what is the most important properties for the customer, and what is our own hypothesis. That's not the same. So, and here you can see also serial levels, but here you can see a little bit different definitions for different serial levels, and I would agree much higher with these definitions than the previous one. So in here you can see that for CRL level number 3, we have first market feedback established. So it means that we go to the customer, show them our prototype, and we get the first feedback from the customer and try to modify our future development way of the product to fit with their demands. So, and here I would say tell you a few words about Rogers diffusion of innovation. The shape of this scheme is the bell. This is a normal distribution, and here the question how we could take the feedback from the customers, from the market. At least we don't have the product. We have only something which is built, which is made of paper, woods, and little bit sticks. Maybe that's not completely. That's not a product. It looks not as a product. How could sell it, and how we can take the feedback. Just remember that market consists of completely different kind of customers. The first two part is innovators and early adopters. And innovators, inventors, sorry, they are really looking for the new innovations. They really would like to try something new because it's new, and this is the who would be help you to develop new product and give you the feedback about how you need to modify your product. Just remember that all market, somewhere in the market, there is about 2 or 3% of the people who really would like to try it, if even that it looks not like a product. Don't worry about that. Then when you take the first feedback and then you modify your product, and when if you have something very close to the final product but not exactly the same, I mean, if you have some industrial prototype already, a full-scale prototype, then it's time to go to the next part of the market, early adopters. They are really also very open, not so open as inventors, but they also would like to, they would be very pleased to try something new, especially if you give them really at least a little hope that it helps them to reach their goals. Okay, and then oops. So, and yeah, here we have, as I told you, in innovators and early adopters is the early market part, and then we have to switch to the early majority, later majority, and laggards. And here we have really chasm between this part, and you really have to get good feedback and find and define the properties which market needs from your product to switch from early market to mainstream market. But don't worry, that's not the unsolved problem. Just keep in mind that that switching from early adopters to early majority is not so easy than the switching between innovators and early adopters, and that's it. Okay, and let's imagine we have projects, some product. We are going to develop some product, and this is our initial readiness level for TRL, MRL, and CRL. Usually we don't start with the TRL level number 1 for all of these readiness level. Also, I would say that usually MRL level MRL number 1 and CRL number 1 starts with TRL number 3. So when we have some only ideas about the product on the basis. I mean, let's imagine the situation from the rocket science. Yes, initially we know that in the beginning of in the end of the 19th century, Tsiolkovsky tried to develop the theory of the space traveling, and this is actually the TRL number 1. And Korolev, it's 1961, sent Yuri Gagarin to the space with a rocket Vostok, and this is the actually full-scale prototype which could work in environment. And now we have completely full TRL number 9, at least for sending satellites to the orbit. And it means that the travel from TRL number 1 from TRL number 2 takes 100 years, and that's pretty common. So Let's come back to our scale, to our axis. So let's imagine that we start with TRL levels, which are marked as a point here on axis, and we need to push it to the TRL to the readiness level number 9 for all 3 axes. And how we have to push it? That's the question. We can just start. Just think. Okay, let's push TRL only, and when we will come to TRL number 9, then we let's start think about how we could produce it. I mean, let's think about after we finished TRL, let's think about MRL, and after that we will think about the customers. This is completely wrong. We need to push it simultaneously, and more or less we have to transfer these levels to the final point, to the point number 9, simultaneously. Actually, you can find that there are really a lot of readiness levels which could be applied for invention project managers. So here you can see the technology readiness level, customer readiness serial, our readiness level, team readiness level, that also appropriate for us, business readiness level, which could be separated from serial. Now, funding readiness level also, why not? IP R means I don't know what means R, but IP means intellectual properties. So this is also might be very important. But initially, actually, these 3 axes would be enough for starting and even for finishing of the most project, TRL, MRL, and serial. And let's come back to our project running, and I would say very important words for at least for us in LMK. Every task which we have in a project, it doesn't matter what we are talking about, serial, TRL, and or MRL. This is the every task is about the hypothesis. We each task is made for generation of the hypothesis or the testing of the hypothesis. And don't worry if the hypothesis would be wrong. I mean, initially people thought that we live in a flat or very on the Earth, which is very flat and which is located for the tortoise and the elephants, and that was a hypothesis. And then they test this hypothesis and go to another geocentric hypothesis, and then they went to the third one, hypothesis, and here the same story. Initially, you have the hypothesis, what should be the main properties of your product, and it could be completely wrong, but you will know it after the contact with the customer, for example, after testing your hypothesis. But initially, you have to generate this hypothesis. Anyhow, just keep it in mind. So, and this is the story about how we manage with the tasks. So we usually use the Kanban board. So we have some tasks initially, and initially they are located in the backlog. We need, for example, we try to check. No, excuse me. We initially we, for example, don't know what to do, and we do some literature review from the patents, from the articles, and so on, and then we could try to modify the technology. I mean, I'm talking about methodology. Yes, we could inject some new elements to the material, and so on. We can try another temperature profile for heat treatment. So we have different kind of ideas what to do and expected results. So, and all of these ideas, they are located in the backlog. And then if we start it for the next period, we put it for the next column selected for development. Not all of these backlog tasks should be implemented in the future. This is just a basket with ideas what we have to do next. Then when the task is being performing, sorry, the task is put in a column in progress. And then it goes to the column done if it's done, and also there could be another column which is failed or postponed or something like that. And if we understand that we don't need to run this task till the end, or we couldn't, and it doesn't sense for us anymore, we put it to the garbage, I would say. So, and each task also contains the following description. Here I put some examples also. So the first description is the goal. What is the goal of our task? And more or less, what is that would be good if you connect anyhow goal for the task for the promotion of readiness level. Any kind of readiness level. From one level to lift it to another one. For example, goal for the task is to find the best combination of the driving factors of some process. The next stage is expected result. So what we decided is the results when we will tell, okay, this is it. This is what we expected, and we can successfully stop this task. So, for example, optimization task is performed based on computational simulation approach. So we have some, for example, finite element simulation, and we would like to find the best, I don't know, loads, thickness of the beams, material combination, and so on. Then the third step is assumed step. We have what is the step? Collection of input, model development, automatization of the model verification, calibration. It means the comparison with the experiment, and the final is optimization. So it means that we develop the finite element model, then we put some kind of automatization. I don't know if you're familiar with ANSYS. There is the specific language which with this language we could automate the model, or with the Python, and then we could solve the optimization task. Oops. The fourth point is the expected result for the next step. This is more detailed part. I mean, let's start with the first collection of the input. And for bullet number 4, we write what is the expected result. It means that in my table is material properties, data about the loadings, what else? I don't know, beam configuration. If let's talk about the bridge, for example, yes, and the drawings of the bridge. So and here, this is what I need to obtain, to receive, to tell, okay, point number 1, collection of the input data is done. So and here we write this information. It's not mandatory to write all these expected results for all of these bullets. I mean, from 3.1 to 3.5. We need at least write the expected result for a next step. That would be enough. The 5 is executor. Next is, for example, who is going to collect the input data? I don't know, my my employee, and when he or she has to do it, and this is the 6th, and the 7th is the log, the history, because actually this task, the period of this task could be very long, at least months, 1 month, a few months. And here, that would be very nice if you, during the model verification and calibration, would be remember some important points, datas about model development and collection of the input data. When you got it, where did you got it, and so on. Where did you get it, and so on. So the log file or log part is really important for us, at least for us in our approach. And by the way, I didn't mention, but what software we use it for us. We use Jira. You can see it here. And Trello. Trello also is the software which is very similar to the Jira, and I guess it's free for a small number of tasks. So you can use it very open and free. I spent 40 minutes for my speech about the project manager, and now I'm going to switch to project portfolio management. But before that, I would like to receive small feedback from you about the ways how I tell you. Do you have some questions? Do you have some maybe recommendations or comments about the previous part?
I think I have some small questions. Could you clarify the difference between a small-scale prototype and large-scale prototype? Maybe some particular example to make it more clear or something.
Mm-hmm. Let's talk about the planes, or yeah, the plane would be fine, or the rocket. By the way, the same. So when I was a child in a school, we made some small rockets made of paper and wood, and I don't know the exact name of chemical substance which we put instead of the engine, but it worked, and our small rockets, something like this size, it flew up to, I don't know, 100 or 150 meters, and in this scale we demonstrated that reactive principle of engine worked. For example, let's talk about the plane, about jets. I don't know if you're familiar with the steps, how to what is the development way of the planes, but initially when a new plane is going to be developed, the small prototype made of wood or made of big piece of metal made for just to blowing in a specific camera to specify the, for example, the curve of the blowing around the plane body, about the around the plane wings, and so on. This is a pretty small scale prototype. If we also let's remember about Musk's spaceship, which he is expecting to send to the Mars, and now he's trying to launch and fly up to, I don't know, 50 meters, and then land it something big, tank. It's completely doesn't look like a starship from sci-fi, but it works. And this is the large scale prototype. This is not what he's going to send to the Mars, but this is demonstration how it's going to work.
Okay, thank you.
Another questions? Okay. Okay, let's talk about project portfolio. What is the project portfolio means, and what is the problem of project portfolio? Let's imagine that we have a lot of ideas what to do. For example, here in LMK, we have a really big shop portfolio, product portfolio. I mean, this is not portfolio of R&D department. I mean, sales portfolio. So we have cold rolling steel, we have hot rolling steel, we have non-grain oriented steel for engines. We have non-grain oriented electrical steel for electrical vehicles. We have grain-oriented electrical steel for transformators. We have ribs, we have beams, we have thick plates, we have cold rolled, I mean, very thin coils. There are really a lot of products which would be nice to develop for. But we really limited in R&D. We are limited. We couldn't do everything, and what we are going to do. And this is the project portfolio management. And when we have the big bunch of ideas what to do, this is not the project portfolio. This is completely not the project portfolio management. When we have such kind of pile of ideas, it's not a portfolio. What is the project portfolio management? We have to answer the following questions. Where idea from the projects come from? What we have to do, and so okay, let's sit around the table and tell to each other. Okay, now we have R&D department. What next? What we are going to do? Next question and answer for the question is how many projects to run? 1, 2, 3, 10, 100, 1000. How many? What projects to run? Okay, we could run the projects about metallurgy. We can run the projects about environment and ecology stuff. Do we need to run a project about electrical engines development? We do the materials for electrical engines, but do we need to develop new engines? Do we need to go to, I don't know, advanced technologies like additive manufacturing? Because powder is not our business. Our business is coils or plates. And the last but not least, when a project has to be stopped, when we have to tell everybody, okay, this cow is dead. Let's stop to to try to make it alive again. So let's start from the beginning, where ideas from project comes from. Actually, for us, we have four sources. The first one, of course, the catch the market leader. Oh, that's our the most, we like it the most way. I would say that's pretty simple. We have our competitor. Competitor has some products which is very demanded for market. We don't have the same product, and we are trying to develop the same product to take some share of the market. That's pretty easy. Customer request. That's very interesting source. But here we have one specific issue. When I tell you about the customer request and the contact with the customer, for us, for R&D, I don't know if it would be important for you in your activity, present activity or future activity, but in R&D, in LMK, for us, it's very important to contact with the R&D engineers for our customers. That's very difficult to find the contact of R&D engineers for of the customer. That's pretty easy to contact with the supply specialist of the customer, but the request of the supply specialist are to reduce a little bit the cost, to improve a little bit the quality of the surface, for example. That's not the R&D tasks. That's not the idea for the projects. But when we are talking with, for example, bridge builders and R&D R&D team of our customer tell us, for example, I'm just dream. Okay, guys, we are going to build new bridge, and we are going to reduce the weight of our bridge, and that is why we need to use the steel with a strength which is higher of the presence one, up to 150%. Could you do it for after I don't know, after 4 or 5 years? Is it would be enough for you? Because now we are trying to develop the drawings, and we are going to start to build this bridge after 4 years, and while we are to drawing this bridge, please develop this still. Okay, that's a challenge for us. That's a good example of the customer collaboration and idea for the project which is come from the customer. Next is the technical forecast. So this is our own, I would say, insight. For example, we just know, I don't know from where, our own entire, I would say, insight. We think up how to improve the strength of the material up to 150%, and we are starting to development this steel. In parallel, we go to the customer and talk with a bridge builder, for example, and ask them, do they need to, are they interested in such kind of product? And the fourth one is the excuse me. Here should be the market forecast, not a customer request, but market forecast. Market forecasts come to us from our sales and strategy department, and for example, sales sees the trend that thickness of the rolling strip for engines goes down. 5 years ago it was 0.5 millimeters. Today it is 0.35 millimeters. Tomorrow the suppliers, the customer needs 0.30 millimeters, and they just extrapolate this trend, and sales told us, the sales team tells us, okay guys, after 4 years we expect that the customer would need the thickness of the strip down to 0.2 millimeters. We know how to reduce from the 0.35 to 0.30, but I mean our technology team, but we completely don't know how to produce 0.2 millimeters. This is the next generation. This is another technology level. Please, let's start think today how after 4 years we could produce 0.2 millimeters for this exact grade. We are not going to change the grade. We're not going to change the properties. Just reduction of the metal strip, and that's it. The next part, or what we need to do with this bunch of the projects, is to rank it. But how we could rank it? Let's start with project features. We could characterize all projects with different kind of features: investments, market or share market of the further product, performance period, how long we are going to develop this product. Just estimation. You never get correctly or estimate anyhow correctly the performance period, but just your estimation would be fine. Present serial, MRL serial, revenue which we are going to obtain, NVP or excuse me, NPV or IRR. By the way, do you know what is it, NPV, IRR?
No.
Me personally, I know what is NPV, but I don't know what is IRR.
Okay, I'll in the end I'll tell a few words. What is it? This is the economical values which could characterize the product and project. So strategy alignment. So for example, yes, as I told you before, we are a metallurgical company. We produce strips, we produce plates, but we do not produce the powder for additive manufacturing, for example. Do we need to switch to these branches, or we don't need? Team experience. We are experienced in conventional metallurgical treatment, but we completely know nothing about the powder, about the sintering, about the what else? SLM means selective manufacturing. Melting, about powder melting. And so on, intellectual properties. So, for example, we would like to catch the competitor. They or he produces some product which we are very interested in, but this product completely defend with the patents. What we are going to do? Should we start or this project or not? So, and etc. You can add something new, which is very important for your team. Or moreover, I would say that we don't apply it yet, but we are going to start it. Initially, today we have only one project portfolio, but today we understand that that's completely wrong, and we need to have at least 2 or 3 portfolios. The first for the project with the TRL from 1 to 3, the second the TRL from 4 to 6, and the third portfolio for the project with the TRL from 7 to 9. Why? Because you completely could not compare the projects with the TRL 8. Let's talk about the rockets again. Let's imagine that you could come to Tsiolkovsky and ask him about his work with the mathematical equations. He starts work, and you start to ask him about the revenue of the flying to the Mars, and or at least satellites launching, and after he would tell you that he doesn't know. Okay, he told him, okay, let's close the project. You don't know the revenue, you don't know the income, even income. So, and that's important that you have your own feature set for different portfolio. That's really important. And then you just the projects travel from one portfolio to another, but part of them could be killed also. That's also an option. Okay, we have, as I told you before, we have some features. Let's imagine that we chose 5 features which is really important for us. Let's imagine that we are talking about only one portfolio. We have TRL, MRL, market size, NVP, and NPV, NPV, and strategy alignment. But we need to remember that the weight of these features is completely different. And we need to estimate anyhow what is the weight of different features. And I could propose you the way how could you do this? Okay, let's imagine that we have such kind of chart, and we could compare the different features in a pair. So as a fight 1-to-1. Let's start TRL, and we have such kind of matrix. and let's compare TRL feature number 1 TRL with with all another features. Let's go to the row, the top row. TRL with TRL couldn't be compared. This is the cross. So TRL and MRL is equal for us. That's our internal feelings. That's not the rule. This is how we internally feel. The TRL and MRL they're equally for us. So it means we put the half point for both. Let's go further. What is the more important, TRL or market size? For us, that's more common. We feel more quiet if we start with high TRL. The project which already have TRL number 7 or 8, even we have the large market. This is our own choice. We would like to go to this is our strategy. That is why we put excuse me. Opposite. For here, I chose that market size is more important for us. I agree that I take some risks, and if I have the large market, that's okay for me. If I take the TRL with a low level, that is why TRL loses in comparison with market size. NPV. TRL is more important for me than NPV. NPV, that's a value of how many money I can earn with this product. Okay, that's better for me to have high TRL than high NVP. Strategy alignment. I don't want to. I just want to develop the product which is in alignment with my strategy. I don't want to start to work with some new products. That's not appropriate for me. So, and that is how we compare TRL with another four features. We do it simultaneously, and you can see that here we have how it's called. For example, if we have for the first row and the third column, we have 0. I mean, TRL versus market size has 0. It means that market size versus TRL should have the 1 point. So this is the opposite. 0 opposite the 1, and 0.5 opposite 0.5. Then we assume all points for each feature. This is the total score. We have yes, we have total score for each features, and then we divide total score by the total sum, which is marked in the bottom, and weight, and that is how we could estimate the weight in percentage. So you can see that the most important for us, it happens. The most important for us that is market size and strategy alignment. The next level of importance, see for us, is NVP. That's revenue. TRL, and the last place is MRL. Okay, and then we could calculate the rank value for each product. And then we, as I told before, we have 5 features. Okay, TRL, MRL, market size, NVP, and strategy alignment. We could, and very important, that all of these features should be equally positive or equally negative. So for example, that's good to have high TRL, and that's good to have high market size, but this is bad to have high investment costs for purchase of new industrial equipment, for example, or for purchase for your laboratory. That's a negative feature. In this case, you have to switch. I mean, for example, we have the equally positive factors. Not the investment, but absence of investments. In this case, you have to put high points if you have low investment, and you have to put low points if you have high investment. That's the point. So we can estimate, and we really do have the points for TRL, MRL. We have the size, number of the market size. We have MVP, and we have the strategy alignment. Also, we could define any points. For example, 3 for each point for each project. Yes, we have completely aligned with the strategy. This is the 3 points. We have the partially alignment with the strategy. This is the 2 points, and we are going to develop this project in completely new for our strategy. This is the 0 point, so 1 point for this feature. That's how you estimate. But also you can increase the scale. You can put, I don't know, 9 points for each feature. That would be more appropriate. By the way, I would advise you to have the same 9 point scale for 9 point axis for all features. That would be the most easy to estimate the products. To estimate the value of the products. And this is how we could rank all of these projects, bunch of the projects. So we can calculate project value based on this top equation. So we have the feature weight, and we have the feature point of I feature. So, and let's imagine that we have projects, 8 projects from project A to project H. And this is the value of the project, which is calculated with the equation on the top. And this is the project costs. It means how much we have to spend for development. We are not talking about the investment for purchase of new equipment for producing. And here we have we are talking about the project cost only for development. Well, and okay, now we have bunch or ranked bunch already, but this is not the portfolio yet. We have the ranked bunch of the project, and how we could what projects we have to choose. Actually, we could choose all of these 8 projects, but what if we have 800 projects? What we are going to work with? We couldn't take 800 projects. The first approach, the most easy approach, I would say, to take top N projects. For instance, you have 5 project managers, and each project manager could run only 1 project or 2 projects. But this is the standard for you, for example, 1 project for 1 project manager. You have 5 project managers. At least you can take only 5 top projects from project A to project E. That's easy. Another approach, you have some threshold of the value of the project value, and you don't take the projects with the project value below some critical value, some threshold. For instance, let's imagine that for us, this threshold is equal to 330. So it means we could take project number from A to F, and we reject projects G and H. That's too that's really a very low revenue and very high risks to work with these projects. We have really low MVP. We have the strategy. The project is not aligned with the strategy. We have low future revenue. That's a bad idea to work with project J and H. And the third approach is to maximize total value at conditions of the limited budget. What does it mean? So we have the project costs. Let's imagine that it's annual project costs. Yeah. And you have some limited budget for annually for the year, and you just choose your project portfolio. You will compile your project portfolio to maximize the total value of your portfolio within the trying to not exceed your budget. That's approach. That's an optimizational task, but very simple. In this case, for example, let's imagine that we have only $10,000 or $11,000. It means, for example, we couldn't choose project A and B because we exceed the 11,000. But we can choose, for example, last 3 projects, and the total value of the portfolio would be 30, 58, 76, 61. Yeah, no. 81. 81. If we just take project F, G, and H, maybe there is another combination how we could maximize the total value of the portfolio. I don't know. I'm just lazy to do this exercise right now. Well, now a few words about NPV. NPV means net product value. And you can estimate with this value, this parameter NPV, cash flow. What is the cash flow? Cash flow is the money which you earn every year by selling this product. But we have to consider that the money which we could earn today, I mean, in this year, I mean, for example, $1,000. It's not the equal of $1,000 which we can earn 2 years after. And here we have to divide the cash flow with the discount rate R. And what is the discount rate? Discount rate is the cost of the funding. I mean, you can take a loan in a bank, yes, and in this case, or put your money in the bank, and in this case, your discount of the rate would be the investment rate of the bank, and minus, so cash flow divided with the 1 plus discount rate in the power of period, I mean year, minus investments divided with the same story. And if you have positive NPV, anyhow, more than zero or more, it means that it's more profitable to you to run the project than to put your money in the bank. For instance, if you compare your NPV with if you compare, yes, your project, if you have two options: to put your money in a bank, or to fund your money to the project. If you have NPV, positive NPV, that you need to start to invest your money to the project. IRR, I don't remember the correct description of this abbreviation, but this is discount rate, which turns MVP for the project to the zero. It means you have the discount rate. For example, usually you have, your company has such kind of projects which discount rate or cost of funding for your company is some specific percent, and if your discount rate is higher, it means that your project will earn more money for your company than usual. Yeah. Well, actually, this is the first time when I as a lecturer take this role, and yeah, that's it. That's all materials from my side, and I have more extra time, even half an hour or maybe 40 minutes, and I don't know what I have to do next. Maybe your
Yeah, Maxim. Thank you very much, Maxim. So it was very great lecture. Guys, Maxim, okay, so they are our very good partners, and we do and did with Maxim several projects. And so if you're interested in to do this project with an LMK and some research and development projects, because Maxim is responsible for these directions. And please welcome, so we can find some interesting topics to you, and let's start. So thank you very much, Maxim. Right now, here is a yeah.
Yes, Michael, thank you for remind that. Actually, I was going to tell a few words about my activity, or what I actually do in my work.
Yep, it will be very.
Yes, unfortunately, I didn't make some slides for this, but anyhow, I tell you. Actually, I'm responsible for development of new non-grain oriented electrical steel for an LMK. And LMK is one of the leader in the world of producing electrical steel. And I'm responsible for the grades which is applied for a different kind of electrical engines for electrical vehicles, electrical cars as well. Well, and during our projects, we apply different kind of research methods, really a lot. We use mathematical simulations, completely different kind of finite element methods, fluid calculation fluid dynamics. Today we are starting to work with the microstructure simulation, the grain size simulation, which is affected with a specific temperature profile or cold work, cold plasticity. We are going to we are working on the model of the recrystallization, different kind of recrystallizations. That's who is involved in this topic really knows that that's a pretty complicated task, and we work with artificial intelligence, and this is only about the different kind of computational approaches. Yes, also we have our laboratories and analytical methods, such as different kind of electronic microscopy, transmission electroscopy, scanning electroscopy, microscopy, electronic microscopy. We have different kind of X-rays investigations, as well chemical investigations. We have our internal lab for physical simulation. So as I told you before, we could melt small ingots, dilatometry investigations, and researches, and cold rolling, hot rolling for laboratory scale, and then after that, of course, we make industrial experiments. This is also pretty scientific-ish, I would say. Well, what else? And for example, with Michael, we worked with the computational CFD approach. We made a big work which is dedicated to mixing mixing period and mixing processes within the RH degasser. This is one of the metallurgical equipment. And now we work on the topic which is dedicated the slag interaction with refractory and the metal in the liquid. I don't know if you're familiar with the big ladle, which is made for keeping the liquid metal, liquid steel, and there are a lot of chemical and physical interaction between the liquid metal and refractory, which covered the walls of the ladle, and that's a pretty interesting and state-of-art work in Russia. That's completely true, and even some partly in the world. So, and we are completely open to involve students in such kind of activities in two kind of ways. Just if you are interested in, please feel free to choose. The first approach is to come to us directly, to NLMK, as interns. We have half a year intern practice in Moscow office, as well in Lipetsk, because all of these laboratories, which I mentioned before, are located in Lipetsk. And also as an optional, another way to be involved in these different tasks, to join to Michael's team.
Yeah, so guys, you have heard that with Maxim, with team of Maxim and me and NLMK, we can start really interested projects. You can join some project which are already doing so, and please feel free, take a look at these opportunities. And again, thank you very much, Maxim, for joining us today.
Yeah, you're welcome. You can ask Michael about my contacts. Actually, again, I had to put it in the screen, but I completely forgot about that. Sorry about that.
Okay, thank you very much, Maxim.
And maybe students have questions about the lectures to clarify some topics.
Yeah, really. Guys, do we have any questions? Okay, no more questions. Okay, let's finish with lecture today, and we'll